Okay, this video is on proving trig identities. It's a continuation from yesterday. We're just going to do a minds on a few more examples. So we're learning to prove a trig identity by showing that the two sides are actually equivalent expressions. So prove each trig identity. So if you remember from yesterday, the first step is to make your left side, right side chart. So the left side of this one is tan squared theta over sine squared theta. And the right side is 1 plus tan squared theta. And then you want to start with the more complicated side. So we could say maybe the fraction side is more complicated. And one of the most important strategies we use is to try to write everything in terms of just sine and cos. So we know that we could write tan squared theta as sine squared theta over cos squared theta. And that's still over sine squared theta. So then we have a fraction in the numerator, and we're dividing by sine squared theta, so we can use the rule multiply by the reciprocal. So we would have sine squared theta over cos squared theta times, if we flip this, we get 1 over sine squared theta. And then we can multiply the tops together, because we're multiplying fractions, and multiply the bottoms together. And then we see that we have sine squared theta on the top and sine squared theta in the denominator, so we can divide them out since everything is multiplying and dividing. And then so this side so far we can reduce it to 1 over cos squared theta. So let's try the same technique on the other side, switching everything to sine and cos. So 1 plus tan squared we can write as sine squared theta over cos squared theta. But then we're adding a whole number and a fraction, so we can get a common denominator of cos squared theta, because the denominator there is really a 1. So the denominator, we had to multiply by cos squared theta, so we have to multiply the numerator by cos squared theta. And here the denominator already was cos squared theta, so the numerator stays the same. Then we can add the numerators over the common denominator. And then on the top here is our most famous identity, cos squared theta plus sine squared theta equals 1. So I can replace cos squared theta plus sine squared theta with 1 over cos squared theta. And then we should notice that now we've proven that both sides are equivalent expressions. So we say, therefore, left side equals right side. Therefore, proven. Okay, another one to try here. Start off the same way. So left side, right side, cos theta, cotan theta, 1 over sine theta minus sine theta. So we might start with the right side because it looks like a fraction again, so we would get a common denominator of sine theta. Here the denominator already was sine theta, so the numerator stays the same. Here we had to multiply the bottom by sine theta, so we multiply the top by sine theta, so we get sine theta times sine theta, which is sine squared theta. Subtract the numerators over the common denominator. When you see a 1 and a sine squared, hopefully you think of some coming up here. Sine squared theta plus cos squared theta equals 1. So if I subtract sine squared theta on both sides, I get that cos squared theta is equal to 1 minus sine squared theta. So that's just using an identity that I know, the most famous identity that I know. So I start off with sine squared theta plus cos squared theta is 1. Subtract sine squared theta from both sides. And then I get that cos squared theta is equal to 1 minus sine squared theta. So that means I can replace 1 minus sine squared theta with cos squared theta. And then, so I've changed everything so it's in terms of cos and sine. I'll come over and try a similar strategy on the left side now. So I want to leave cos theta as cos theta, but cotan theta, that's one of our bridging identities. Cotan theta is the same as cos theta over sine theta. And then we can just multiply the fractions top by top. So cos theta times cos theta is cos squared theta. Bottom by bottom, 1 times sine theta is sine theta. And then we should notice that, again, we've proved that both sides are really equivalent expressions. So we do our therefore left side equals right side, therefore proven. So in both cases, we've used that fact that of being able to write things in terms of sine and cos. So that's one strategy we've used. We've also used that really important identity that sine squared theta plus cos squared theta is equal to 1. So that's a very important identity that we use, okay? We've also used our bridging identities, and those are that tan theta is the same as sine theta over cos theta, or that cotan theta is the same as cos theta over sine theta. So those bridging identities help us put everything in terms of sine and cos so that we can try to match the sides. So two very important strategies. Okay, moving on. So C, we'll start off again with the chart. Left side, right side. 1 minus tan squared theta over tan theta minus tan squared theta. And 1 plus cotan theta is on the right side. So obviously the left side looks more challenging. It's all in terms of tan right now. In the bottom, I noticed that I could common factor out tan theta. And then I would get 1 minus tan theta. And the top, this 1 minus tan squared theta, is actually a difference of squares. So you can think of it, I'm going to move down for a bit. If we had 1 minus x squared, it would factor to give me 1 minus x, 1 plus x, because that's how difference of squares factors. Remember, it matters which one comes first. It goes at the front of each bracket, the square root. Square root of the second goes at the end of each bracket, and then opposite signs in the middle. So if we apply that to 1 minus tan squared theta, it would factor to give us 1 minus tan theta times 1 plus tan theta. So everything's multiplying. We have two factors multiplying in the numerator and in the denominator. So we can divide out 1 minus tan thetas, and we're left with 1 plus tan theta over tan theta. But we could split that up into two fractions that both have a denominator of tan theta. So this is another technique that's often used in identities. So 1 plus tan theta over tan theta is the same as 1 over tan theta plus tan theta over tan theta. But we know from our identities that 1 over tan theta is cotan theta. That's a reciprocal identity. And we know that tan theta over tan theta is 1. And if you look on the other side, that's exactly what we have over here. So without even manipulating the right side, we can see that the left side and the right side are equal, which means that the identity is proven. Okay, so this technique here of we have a fraction over a denominator and then splitting it up into two fractions with the same denominator, and then using our reciprocal identity, and then just the fact that something divided by itself is 1. Okay, go for our last identity here before you do a bunch of practice today. So right now I'm looking and I'm seeing that on the right side, everything's already in terms of sine and cos. So I'm not going to touch it right now. I'm going to look at the left side where I'm hopefully going to be able to write things in terms of sine and cos. So first of all, I might say that I know sec is 1 over cos theta by the reciprocal identity. And 1 over cotan is tan theta. But then I know that I can write tan theta using the bridging identity as sine theta over cos theta. So what have I done so far? I looked at sec theta and used the reciprocal identity to write it as 1 over cos. And then I saw 1 over cotan using the reciprocal identity was tan. But I know tan using the bridging identity is sine over cos. So now I'm at the point where I'm adding two fractions, but lucky enough they have the same denominator already. So I can just add the numerators over the common denominator. And what do you know? We have the same thing on both sides. So therefore the left side equals the right side, therefore proven. So again, that technique involved reciprocal identities and fractions again, adding fractions. So those are the 4 examples we're doing as a warm-up, and then you'll have the rest of the period today to keep working on Group A and Group B identities. Try as many as you can. Try them yourself. Remember, my solution isn't the only solution, but ask a friend or a partner to go through your solution if it's different than mine, and make sure that what you've done is mathematically valid. As long as you don't do something mathematically incorrect or use something that's not an identity, it should work out. There should be many different pathways to getting the sides to match. Okay, so our success criteria are that we can rewrite one or both sides of a trig identity so that both sides are in terms of the same trig functions, usually sine and cos. We can use strategies such as expanding, factoring, simplifying, and finding a common denominator to find an equivalent way of writing a side. I can use the chart format to organize my proof and help me to work on one side at a time. And once I've shown that the left side and right side are actually equivalent expressions, I conclude my proof with a therefore statement. All right.